Hi friends, good morning to everyone. In the last session, we have explored the rules of function overloading. Previously, we have discussed the general form of defining functions in C++ language and how to call the functions and how to define the inline functions, how a functions can set default arguments and the corresponding values. Finally, right, we have discussed what is function overloading, how to provide some special tasks or additional tasks to the functions so that having same function name by differing the number of parameters or in type of parameters or both in number and type of parameters, the overloaded tasks for the functions are defined. We have seen right how the function overloading rules are executed, and we have verified right the rules when there is an exact match between the actual and the formal parameters, and how the C++ system right automatically C++ compiler automatically performs the automatic type promotion rules, and even when automatic type promotion rules are failed, right, how right the ambiguity is rising and how the compiler reports the error messages. These things that we have discussed in the last session. Have any queries in function overloading? Do you have any queries or doubts in function overloading? Srinidhi, Ganga, Pavitra?
No, sir.
Okay, very good. Now we are going to see the next important topic called manipulators, right? Manipulators, these are right functions. Manipulators are simply special functions. Manipulators are simply special functions that are defined in the C++ language. The special functions which are modifying the input output operations of the C++. That means these special functions modify the role of greater than operator or less than operator. There are different manipulators as we have seen previously, right? D and DL. This is one manipulator. In case if you want to force the output in a new line, we need to write cout less than slash n semicolon slash n semicolon, right here the we need to focus the output in the new line because slash n, right, this is a new line character. This can be right indirectly achieved with the help of a manipulator. Instead of typing opening quote slash n closing double quote, right, simply write or one can easily type endl. So this is the easiest style. If you prefer write cout, right, typing double quote slash and double quote semicolon, no problem, right? So whichever is we can use. This is the task of right manipulator, right, endl, a special function, right, that is used to force the output in the new line. Like endl, right, as some other functions are defined in the header files iostream.h and iomanip.h. iostream.h. Some manipulators are defined in this header file. Likewise, some parameterized functions are defined in this header file. In this header file, iomanip.h, io manipulation header file. Now, first we are going to explore some of the manipulators defined in iostream.h and iomanip.h, and then right we focus on the next important topic in a function called recursion. First, let us focus on the different or predefined manipulators defined in the C++ language. Have a look into write this a turbo C++ a code. Hash include iostream.h int main. Consider here we like to return one integer value to the calling place. Return 0. Consider the declaration statement. For example, int x is equal to 100. Now we like to print the value of x. Cout less than x is equal to less than x less than endl. Endl already we have explored, right? One manipulator that forces the output right into a new line. Now let us see the manipulator called hex. Cout hex x is equal to less than x less than endl. Now let us check the outcome of this program. Save the file as cexx, next file name 17. F9. Program has been compiled successfully. Pressing Control F9, you can see the resultant value. X is equal to 100, then the hexadecimal value is shown as 64. Here hex, right? Hex is a manipulator which is defined in the header file iostream.h. Simply, right, when you say right hex, what happens? The current output is right converted into the hexadecimal one. For example, have a look into here. See how the outcome is right converted from the decimal system into the equivalent hexadecimal system. 100, right? 100 is stored in the decimal value. If you write a cout less than hex, whatever your current system, the current system, this is converted into the hexadecimal one. For example, 100, converting 100 into the hexadecimal, base is 16. 6 into 16, right? 96. Reminder is 4. So 100 in decimal, this is equal to 64 into hexadecimal. So subsequently, right, if you write to print some other number, for example, cout less than, I do like to print the value of another one or define the variable here. Because in C++ we can dynamically initialize the variables and we can declare the variable cout less than y is equal to less than y less than double quote slash n, or you can use a manipulator env. In this case, file save, compiling and running the code. What happens? 125, 125, what happens? Is transformed or right converted into 7b, because here 7 into 16, right? You need to find the remainder value 125. 125, converting this into the hexadecimal one, 7, right? 7 into 16, 112, right? What is the balance? Balance is 13. You know that A is 10, B is 11, C is 12, D is 13. So reminder is here 13. Writing this in hexadecimal form 7D 16. This is equal to 125 in decimal. So that's what here we have the output y is equal to 7D. Understand or not? Understand? Say yes or no. If you have any queries, you can ask.
Understood, sir.
Once you set the value hex, what happens subsequently are in the current input output system, the output formatting is focused to hexadecimal 1. In case, right, I do want to revert back to the normal system. Our normal system is only a decimal system. In that case, right, to revert back, use Cout less than DEC, right? DEC, which means that, right, this is the decimal system. For example, in decimal system, we are printing a value 100. Control F9, closing the output screen. Control F9. You can see the value 100 because here hexadecimal setting, right, that has been reset, right, a reset to the decimal one. So once you set explicitly, it is a role of the user to reset the current setting. So again, right, this is converted to a decimal one. Now, right, another manipulator is Cout less than OCT, actual value, right? So in actual, right, we do want to print the value of 1000. Control F9. So continuously, right, it shows 1000, then it shows the value 1750. So 1000, right, this is stored in the form of, right, the decimal system, converting 1000 into the actual equivalent 1, 186, remainder balance 220, 2 8s are 16, 4, 40, 5 8s are 40, then 8, 125, 0, then 188, 4, 45, 5 8s are 45, then 8, 186, balance is 7. So we have 1750, 1000 in decimal. This is equal to 1750 in active. So that's what here we have the result 1750. Hex to convert, right, this into a hexadecimal format, then OCT, right, to convert the outcome, right, into the actual format, and DEC, right, decimal system. So whenever you want to reset, right, this can be reset using DEC. Suppose 12578, control F9. Control F9. Now the outcome is, right, updated, right, 12578. Another important kind of manipulator is this one. Have a look into, right, see out. Hi, how are you? Listen, B and DL. At the beginning, right, let us introduce one new line manipulator. Control F9. You can see the message, right? Hi, how are you? Now, in case, right, if you want to leave a space, right, one space, we can modify the statement like cout less than ENDL, hi less than ENDS less than how less than ENDS less than R less than ENDS less than U less than ENDL. Now let us check the outcome of this manipulator. Control F9. Find hi, how are you? Right? So after that, right? How are you? ENDL. This is the end of line a character. So it seems the output right after ENDS. What happens? One space is occurred. Control F9. I space, right? O space, R space, right? One space is occurring. The space is right because of the manipulator ENDS, right? So ENDS, right? The purpose is to output a space. In case if you want to write introduce ENDS, right? Many times. For example, cout less than ENDS, cout less than I less than ENDS less than less than how are you? Let us check in this case each ENDS leaves one blank space. Here it says right after I we introduce twice ENDS manipulator. So it outputs a single blank space. So I right ENDS twice. So two blank spaces are output here. Each ENDS outputs a single blank space twice. Then hover. Understand the purpose of this one. ENDS. Another one manipulator. File save. Consider the next code. File new. Hash include iostream.h into main. Consider the code return 0 here. We do like to write define right another manipulator called set field. Int x is equal to 1 2 3, y is equal to say 5 6 7. Set field right it sets a character, right? So we need to set a character using set fill method. For example, set fill cout less than set fill the character star has been introduced less than x is equal to less than x less than y is equal to less than e and d. Then let us check the effect of this set fill first. I say we need to define the field with also. Set fill is a manipulator that takes a parameter. So whenever a manipulator takes a parameter, the parameterized manipulators are defined in a header file io manip.h io manipulators. So hash include I am including another manipulator called io manip.h. File is saved. Control F9. You can can see the result. X is equal to 123 because the width of x has not been set. Likewise here, slash d y is equal to less than y less than e and dl. Control F9. X is 123 slash t because of slash t, right? It says spaces. Y is equal to 567. In case, right, if you want to set the width, right, for example, C out less than set W, suppose field width is 7, file, save, whatever you want to output, we want to output, right? C out set W, what is the error message? Illegal structure operation in function main. Set W 7 less than. Let us continue the filling operation. File, save, control F9.
Sir, in cout statement 2 less than, sir.
Cout, yeah, thank you. One less than is missing. File, save, control F9. Previous case also a correct one, right? Let us check. Cout less than. Set W of 7. Let us close file, sorry, file, save, control F9, fine. We can write cascade, right? A normal rule, as we discussed in the first, second sessions, right? We can cascade, right, the outcomes, or in a multiple cout statements, you can write. Here, whatever you want to output, x is equal to, right? This should be output in a field width of 7 characters, right? So x is equal to, right? So this is output, right, in a 7 characters. So 1, 2, 3, 4, 5, then 6, 7, x is equal to 123. Then y is equal to, right, the value 567 is printed. For a better way, right, if I change from this into simply cout set fill character, right, star less than x less than e and dl, highly save, control F9, you can see the outcome. X, the value of x is 123. This is formatted according to 7 characters. With is 7, 1, 2, 3, so 4, 5, 6, 7, right? So previously it seems written 4 leading source are there. Let us print the value of y. Cout less than y less than e and dl. Cout less than 1, 2, 3, 4, 5. Control F9. First the settings only, right, the filling effect has been set for only x, the set fill has been set. Then for the remaining outcomes, right, 567 1 2 3 4 5, right, the settings is not possible. So in case if you want to set explicitly, here we need to write set fill, for example, hash less than y less than e and dl. Likewise, cout here set fill, for example, a question mark, single quote, less than 1 2 3 4 5. Control F9, closing and bracket, parenthesis missing. File, save, control F9. we can see, right, the set W, right, this has the effect, right, only one time, right? So to set, right, further case, here we can use set W of 10, listen. Here if you want to set a new effect, set W of 12, listen, set fill. In this case, control F9. So for every output return, you need to explicitly set, right, the set W as well as, right, set fill character should be explicitly set. Then, right, 1, 2, 3, 4, 5, 6, 7, 7 hashes are there, followed by 5, 6, 7. Then set fill character, right, 1, 2, 3, 4, 5, 6, 7. Then 5 digits are there, 7 plus 5 at 12. In case, right, you need to check, right, how will be the effect when we set like see out set W of, for example, 5 lesson set till the character is set, for example, plus lesson. We do want to display the value 1, 2, 3, 4, 5, 6. In this case, what happens? Since the field with the have been set explicitly 5, you write one ENDL, listen, file, save, control F9. Here the field width have been set, right, to 5 characters. In case if you have, right, a more number of characters, right, than 5, more than 5 characters, then the fill character is ignored. So whatever you are typing, right, whatever you want to output, 1, 2, 3, 4, 5, 6, for example, the same output is given without the filling a character. So be careful, right? Set fill and set W are associated. So wherever you want to write, set the width, right? And if you want to write fill the specific character, you can use the set fill method. Set fill and set W, right? These are said to be the parameterized manipulators. The parameterized manipulators are defined in the header file iomanip.h. Another one is a set base. We can also set a base, right? Similar to the actual hexadecimal and decimal one. See this code hash include iostream.h to make. Some of these manipulators are not given in your syllabus, but anyhow, right, you try to learn the int return 0. Learn these manipulators return 0. Here declaring something int x is equal to 123, y is equal to 456. We can set the base, right? You can set the base like this. Cout listen, set base 16 listen x listen slash t listen y listen dn cexx save the file cexx19 control F9 set base takes parameter, so include the header file iomanip.h hash include iomanip.h control F9 it's says, right, what is outcome? One is 7b and another one, this is 1c 8. So the outcomes are right in the form of right a hexadecimal one, set base at 10. In case we want to write convert this into the actual system, set base 8 less than x less than slash t less than y less than d and dx. F2 control F9. So 173 right and 710. The inputs are converted into the actual system. Then coming back to the normal system, the Cout less than PEC less than X less than Y less than D and D. F2 control F9 1 2 3 4 5 6. The outcome is right again right converted into the decimal system, or you can use set base the value 10. F2 control F9 1 2 3 4 5 6. You cannot write you try to write set some other right system, for example the number system right 5. So checking control F9 1 2 3 4 5 6. We want to set the binary system to control F9. We cannot write have the effect of written other number systems. So the supported number systems for the set base manipulator are right decimal right or denary system, octal system and hexadecimal system. These are some of the manipulators, right? Manipulators that takes parameters. So the parameter, the manipulators are defined in the header file called iomanip.h. You can also define the equivalent iOS number functions, right? iOS dot with iOS dot, right? You can set right the corresponding with right field characters. The equivalent iOS functions are also there, but right you try to go through right some of these manipulators, right? So these manipulators are useful for making the easier conversions from one system to another system. That means one number system into another number system. Next we are going to see right the important concept called recursion in C++. Recursion, can you tell me what is the recursion? What is recursion?
A function
I
calls
already
itself.
taken the same. Yeah, function call.
When a function calls itself.
Function calls itself, right? I already explained the same in a C language. Very good. Function calls itself, right? That is the recursion. Have a look into right this. Suppose f is a function. Assuming that the function f has been defined like this, f of something, opening categories, closing categories, have some set of statements here. When this is the function definition and this is a function call, what happens during the function call? Control is transferred to execute the function definition. After the complete execution of these statements, then control comes back to execute the next statement following the function call statement. You can call the functions any number of times, right? So this is the normal, right, rules to be followed. Here function name, right? Here function name, this would be the same. Number of parameters, type of parameters, number of parameters, type of parameters, right? There should be a match between here. These parameters are said to be actual parameters. Here the function parameters, these are said to be formal parameters or formal arguments. There should be a one-to-one correspondence between the actual and the formal parameters. Now consider this scenario when a function f is called, assuming that this is the function definition f opening curly brace, closing curly brace. In this function definition, we have one function call. Suppose if it calls right another function, for example here g of something, no problem. Assuming that g is the function here, opening and closing curly brace on statements. This is the function g. From right the function f, control is transferred to call the function g. After the complete execution of g, control comes back again to call the next statement in function f in the sequential order. Suppose instead of function g, have the same function f. That means here assuming some statements are there, here some statements are there. This is the sub function, right? User defined function. Assuming right this is the main function, opening curly brace into main and closing curly brace. When a function f is called, control is transferred to call this function definition. Assuming that here unconditionally or unexpectedly we are calling the function f means assuming here two subsequent statements are there following this function call. Without executing the subsequent statements, control again goes to call the same function f. So that means f calls itself, function f calls itself. When a function calls itself, this is to be the concept of recursion. Recursion means right, the function is calling itself. So when f calls itself, the sequential statements inside the f, these are executed. Assuming that right after two executable statements, then function calls itself f. So what happens? F is calling itself, right? The next time this way. Then the statements are executed in the sequential order. Then function is calling itself. So next stage, right? You are calling the function. So cyclically, right? Even infinite number of times, function is calling itself. So there is no termination. So that control will not come out of this recursive function call. Then these statements will never get executed because here assuming right in the simplest level formal parameter is nothing, here in the function call actual parameter is nothing. So simply calling, having this scenario, function calls itself, right? That is true. So unexpectedly, right, infinite number of times or cyclically the function is executing, so that it seems control will never come out of the function, right? Even this recursive function called f, right? So this is to be the indefinite recursion, right? Infinite, right? Or cyclic execution of the recursion. This should be avoided, right, in the program, because the program can be defined, right, using the structured programming, right, with recursion or without a recursion. We need to define a proper termination conditions for the recursion. So to define recursion, what is necessary means we need to concentrate on what is the actual parameters of the recursion and what is the formal parameters of the function definition, actual parameters in the function call, and what is the formal parameter or what are the formal parameters in the function definition. This should be right clearly checked. There must be a proper condition, right? That is to be a termination condition. The termination condition defines when to terminate the recursion, when to terminate the recursion, and we need to define, right, the recurrence relation or recurrence relation. This is something what recursive call. Here specify, right, the condition to call the function itself, or when to call the function, right, itself, and when to terminate the recursion. These two things are very important in defining recursion in or defining the recursive construction in programming languages. For example, you might have seen, right, the factorial, n factorial. N factorial is actually 1 into 2 into 3 into etc. n. The product of first n natural numbers defines the factorial of the given positive integer n factorial. So in this case, right, we can define a function. For example, n factorial, this is equal to n into n minus 1 factorial. This is true when n is greater than or equal to 1. And we can define n factorial is equal to 1 when the actual parameter n becomes 0. So in this case, when n is greater than or equal to 1, here the same function, right, factorial is called. So this is the recurrence relation. This is said to be the recursive call. The recursive call or recurrence relation. When the function name, right, factorial is not available in the right hand side, there we are terminating a recursion. So proper termination condition is expected. Proper recurrence relation is also expected when defining the recursion. So when the actual parameter n becomes 0, we are terminating a recursion by returning a value 1. So this is said to be a termination condition. Termination condition of the recursion. Specify carefully, right, the termination condition and recursive calls during the recursion. For example, we can solve, right, this recurrence relation. N factorial is equal to n into n minus 1 factorial. Then n factorial is equal to 1, right? In these recursive call and termination conditions, here we can define a function fact like this: n factorial is equal to n into n minus 1 factorial. This is true when n is greater than or equal to 1. N factorial, right? This is equal to 1 when n becomes 0. So clearly, right, this is said to be the recurrence relation. We can make this as number 1. This is the termination condition, right? Marking this is number 2. So solving, right, the recurrence relation by using the substitution method, we have equation 1, this implies how the termination condition and the recurrence relation computes the exact value of n factorial. For that, right, we need to solve the recurrence relation using substitution method in our case, for example, right? So using substitution method, we need to repeatedly substitute the value of actual parameter in the left hand side of the function, and this process is continued right until the recursion disappear in the right hand side. This is a way to solve the recurrence relation using substitution method. So 1 implies n factorial is equal to n into n minus 1 factorial from 1. This is equal to n into, to find out the value of n minus 1 factorial, right? So if you put n is equal to n minus 1 in equation 1, we have n minus 1 factorial. Putting n is equal to n minus 1 here, we have n minus 1 factorial is equal to, putting n is equal to n minus 1 here, this becomes n minus 1. N into n minus 1 factorial becomes n minus 1 into n minus 2 factorial. So clearly this is equal to n minus 1 factorial. Substituting the right hand side of this one, here we have n minus 1 into n minus 2 factorial. Extending the recursion, right, one more stage to find out, right, the n minus 2 factorial here, because the recursion is still appearing, we need to terminate, right, the recursion, or we need to expand the recursion, right, one more stage to find n minus 2 factorial. We can put n is equal to n minus 2 in equation 1, so that n minus 2 factorial is n minus 2 into n minus 2 minus 1, we have n minus 3 factorial. So substituting the value of n minus 2 factorial in this equation, we have n minus 2 into n minus 3 factorial. Initially, right, it seems that n into n minus 1 factorial. Next stage, n into n minus 1 into n minus 2 factorial. Next stage, n into n minus 1 into n minus 2 into n minus 3 factorial. So if we extend the recurrence relation, in one stage we have n into n minus 1, n minus 2, n minus 3, etc. n minus 1 factorial. So simplifying this n minus 1 factorial, we have n into n minus 1, n minus 2, n minus 3, etc. n minus n plus 1 factorial. Cancelling plus n and minus n, we have a value 1 factorial. So finding the value of 1 factorial, substitute n is equal to 1 in equation 1, we have 1 factorial is obtained, right? So 1 factorial is equal to 1 into 1 minus 1 factorial, that is 1 into 0 factorial. So by extending the recursion, right, one more stage we have, that is in the left hand side, n factorial is equal to n into n minus 1, n minus 2, n minus 3, etc. Finally, we have the value of 1 factorial. That 1 factorial is substituted from this expression as 1 into 0 factorial. Substituting that value, here we have 1 into 0 factorial. Now have a look into the termination condition. The recursion terminates when the actual parameter n becomes 0 because here there is no factorial function defined in the right hand side when n becomes 0. So when n becomes 0, clearly the value to be returned is 1 because 0 factorial is 1. So terminating the recurrence relation here with 0 factorial is equal to 1. That is from equation number 2. Now we have n into n minus 1, n minus 2, n minus 3, etc. 1 into 1. So rewriting right from right to left, we have 1 into 2 into 3 into etc. n minus 1 into n. So this is the value of n factorial. Hence, when we define the recurrence relation with proper termination condition and proper initialization, we can achieve the actual value of an n factorial. So properly define n factorial as n into n minus 1 factorial. This is true when n is greater than or equal to 1. And when n becomes 0, right, the factorial value is set to 1. So carefully defining the termination and recurrence relations, we can control through the corresponding things in the function definition. For example, we can write a function definition to find the value of factorial. We can find the function definition, right, to find the value of a factorial. For example, here function definition. We can define a function, for example, fact of int n. In the function definition, you need to specify clearly the termination as well as recurrence relations. Now we can terminate the recurrence relation first. For example, what is the second equation? When n becomes 0, the value to be returned is 1. So check here it. If n is equal to 0, then the value to be returned is 1. Else, what we have to find? We need to find this result, n into n minus 1 factorial. So n into n minus 1 factorial, that can be returned here. Else, n into fact of n is a function call to find the value of n factorial. So to find n minus 1 factorial, we need to replace the actual parameter as n minus 1. So write here n into fact of n minus 1. This should be returned, right? So properly write the return statement, else return n into fact of n minus 1, right? Else what? This is true when n is greater than or equal to 1. When n becomes 0, right, the value to be returned is 1. This is the terminating condition, and this is the recurrence relation or recursive relationship. Assuming here the value to be returned is of integer type, return type, function name, parameter list, opening and closing curly braces. Inside this, right, if this condition is true, return a value 1. Else return n into fact of n minus 1. In this case, we can have a function call, for example, f of 5. assuming the function call is fact, right, or a fact of 5. How fact of 5 is executed? When fact of 5 is called, what happens? Here I write fact of 5, for example. What is 5? 5 is the actual parameter. The actual parameter is passes a parameter to the function definition. So here n receives the value 5. So I do the trace. If n is equal to 0, return 1. Else return n into factor n minus 1. So when factor 5 is called, right, this implies that n is not equal to 0. So it calls return n into factor of n minus 1. That is here. This is 5 into factor of n minus 1 is 4. Then factor of 4 is called. When factor of 4 is called, the actual parameter, this one, 4, that is n, right? This n is not equal to 0. So it return 5 into then factor of 4. Factor of 4, what happens? It returns 4 into factor of 4 minus 1, 3. Then when factor of 3 is called, this returns a value along with the product 3 into, because when factor of 3 is called, n receives a value 3 not equal to 0. So it returns 3 into factor of 3 minus 1 is 2. That means return 5 into 4 into 3 into factor of 2. When factor of 2 is called, actual parameter is 2, which is not equal to 0. So it splits further or it invokes a recursive call 2 into factor of 1. Then return 5 into 4 into 3 into 2 into factor of 1 is called, it invokes the next recursion as 1 into factor of 0. Then it invokes 5 into 4 into 3 into 2 into 1 into, when factor of 0 is called, here factor of 0, since n becomes 0, this return 1 time returns a value 1. That is only when in the termination case. So replacing right factor of 0 with the returned value 1 here, right? Here no more recursion. Here function call fact. Here function call fact. This is a recursion. First call of recursion, second call of recursion, third call of recursion, fourth call of recursion, fifth call of recursion. Then in the fifth call, recursion is terminated, so that we have a value 5 factorial is equal to product of, right, 1, 2, 3, 4 and 5. So n factorial is equal to 120, right? This implies n is equal to 5. 5 factorial results in 120. This way the recursion, right, functions are called. There we need to specify a proper termination conditions and a proper recurrence relation is required. Depending upon the problem, we can specify one or more termination conditions. It is not necessarily to have a single termination condition. As far as factorial is concerned, right, when the actual parameter becomes 0, since we have 0 factorial is 1, only one termination condition is enough here. But for some problems, right, that may require more than one termination conditions. That stage, right, when the specific condition is met, what is the value to be returned? That should be properly defined. And when the condition is satisfied, right, or when to specify the recursive call, right, that should be clearly mentioned. So proper recurrence relation, proper termination conditions are required to solve recursive applications, to solve the recursive applications. In the next session, right, let us convert this recursive function into the C++ program, and let us check how many times the recursive function is going to be called. If you have any queries, you can ask. Have any queries? Having any queries?
No, sir.
Okay. What about others?
No, sir.
No, sir.
Okay, thank you very much. I will post the materials right after some time. Please go through it. I have already given the exercises right in function overloading. You need to complete that, right? So in the next session, right, we will complete the recursion, and I will give you right some examples, right, so that you can practice the recursive concepts using those examples. Okay, thank you very much. Take care.
Thank you, sir.
Thank you, sir.
Thank you, sir.